I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. So in this session, we will discuss some definition and terminologies related to Module 5. So here the Module 5 is about 8051 microcontroller architecture. So before going for the definitions and terminology discussion, we will first see what are all the topics we have covered in the Module 5. So Module 5 is about 8051 microcontroller architecture. So in this module, we have discussed about what is microcontroller, what are the differences between microprocessor and microcontroller. Then we have come for how the microcontrollers are classified, that is how it is classified based on bits, based on memory, based on the architecture, based on the instruction set, how many types of microcontrollers are there, and we have seen in order to perform any application, how to choose a microcontroller. So what are different criteria we have to see before selecting a microcontroller, and what are the advantages of using microcontroller instead of microprocessor. And then we have come for discussing about 8051 microcontroller in detail. So before going to 8051 microcontroller, we have started with what are the features of 8051 microcontroller. That means what are different components that are available inside 8051 microcontroller, and what is the capacity of that components. And next we have gone for the pin configuration of 8051 microcontroller. So in the pin configuration, we have seen it consists of 40 pins. So some pins have only single operation, whereas some pins are having twofold roles. So we have discussed about the function of each pin in 8051 microcontroller. Next we have gone for 8051 microcontroller architecture. So in the architecture we have seen what are different blocks that are involved in 8051 microcontroller. That is how about oscillator circuit, timing and control circuit, what are different timing and control signals, what are different registers that are available like A, B, program counter, stack pointer, program incrementer, and we have seen ROM, RAM, what is the internal sizes of ROM and RAM available. Okay, how about the ports, 4 ports, each port consists of its own latch and driver circuits, and then we have seen temporary registers are there, and next coming to ALU, result of ALU reflecting on the flag register. So all these are different blocks we have observed in 8051 microcontroller architecture, and we have discussed about the operation of each block. Next we have gone for the register set of 8051 microcontroller. We have seen what are different registers that are available, like general CPU registers like A, B, okay, and also some timer registers like TCON, TMOD, and some registers related to serial communication like SCON, SBUF, PCON, and some registers related to interrupts like IE register, IP register, interrupt enable, interrupt priority. All these are the registers that comes under this register set of 8051 microcontroller. And we have seen what is meant by timer and what is meant by counter, what are the differences between timer and counter. Later we have discussed about what are different modes of operation of timer. And next we have seen serial port operation. So in this we have discussed how to set the baud rate, how to perform the serial communication by using UART. Okay, what are different registers involved to perform this serial port operation like SCON, SBUF. So all these registers we have discussed. Next we have gone for interrupt structure of 8051 microcontroller. So in this interrupt structure, we can see what is meant by interrupt, how many types of, how many sources of interrupts are there. Okay. So how about the interrupt structure of 8051? How to handle the interrupt mechanism? How to handle the interrupt when it comes at 8051 microcontroller? It says the interrupt handling mechanism. Okay. Next, we have seen how to interface different I/O devices to 8051 microcontroller. So in this topic called memory and I/O interfacing with 8051. That means here generally I/O devices will be interfaced to 8051. And as we have seen, what is the main advantage of 8051 microcontroller means it consists of internal ROM and RAM. But if that amount of ROM and RAM is not enough, there is also possibility of interfacing memory to 8051 microcontroller. So in this concept, we will learn how to interface memory like ROM and RAM, and how to interface different I/O devices like stepper motor, LCD, ADC and DAC. All these are different I/O devices. So we will learn how these I/O devices will be interfaced to 8051 microcontroller. So this is all the concepts we have studied in this 8051 microcontroller architecture. Now we will go for different definitions and terminologies related to all these concepts. So first one here, how time delay is generated in a microcontroller. That means in a microcontroller, generally how time delay is generated. So in the microcontroller, we have inbuilt timers and counters available. So with the help of that only the time delay will be generated. So timers and counters will be used to generate time delay in 8051 microcontroller. Now, so here among these timers and counters, especially timers are used to produce the time delay, whereas the counters are used to count the number of events happening outside the microcontroller. Next, second one, what is mode 0 and mode 1 in timers? So as we know here, timers, they are used for producing the time delay. These timers can be operated in different modes, that is mode 0 and mode 1. So coming to here, when the timer is operating in mode 0, it is called as 13-bit mode. Okay, so it means the timer operation are going to complete with the help of 8192 pulses. Because in mode 0, the timer will be acting as a 13-bit timer. Now, so when the timer is operating in mode 1, it will be acting as a 16-bit timer. So it is going to complete the execution with the help of pulses. So the number of clock pulses will be 65,535. So these are mode 0 and mode 1 are different modes of operations related to timers. Now, so what is meant by microcontroller? So a device that contains a microprocessor with integrated peripheral devices, that is components like memory, that is ROM and RAM, and serial ports, parallel ports, timers, counters, interrupts, data acquisition interfaces like ADC, DAC, okay, it is called a microcontroller. So generally for a microcontroller, we will have all these components that will be present inbuilt along with microprocessor and different peripheral devices like timers, counters, memory, serial ports, I/O ports. All these things will be present inbuilt. Next, so which pins acts as alternate function for the port pins of port 3? So generally we know 8051 microcontroller consists of 4 ports. Okay, so port 1 is a dedicated port, whereas the remaining 3 ports has 2 functions. So here they are asking for port 3, alternate functions of port 3. So here one function is it can be used as simple IO port. Another function is alternate function of port 3 is it can be used as read, port, write. Okay, 2 timer pins are there and 2 pins are related to interrupts and 2 pins are related to serial communication, that is transmitting data and receiving data. Okay, so all these are the 8 alternate functions that are assigned for the 8 pins of port 3. Next, so what is the function of PSEN and EA pins in 8051 microcontroller? So 8051 microcontroller is a 40-pin IC. Among that, EA and PSEN are the 2 pins. So here PSEN stands for Program Store Enable and EA stands for External Access. So what is the function of these 2 pins? So the function of this PSEN is, so PSEN stands for first Program Store Enable. So based on this PSEN signal only, the external ROM holds the program code. In order to hold the program code, so the pin will be connected to OE pin of the ROM. That means here PSEN signal will be connected to the one of the pin of ROM, that is OE. And what is the function of this EA pin means? EA stands for external access. So it stands for external access. It is the input pin. So using this EA signal only, it is used for accessing the external memory interfacing. So if you want to have any external memory to interface, with the help of this EA pin only, it is possible. Now, so define microprocessor and microcontroller. Now, so microprocessor has a standalone CPU, that means it is just a processor, whereas microcontroller has different components embedded inside. What are different components means? It will have internally CPU, that is processor, and it also consists of internal memory, that is ROM and RAM, and it also has IO ports, along with the timers counters are available, serial ports are available. So all these things will be embedded on a single chip. So this is the main difference between microprocessor and microcontroller. And what is the significance of EA line of 8051 microcontroller? Okay, so EA line or EA pin or EA signal, so it is nothing but function of the pin. So microcontroller, 8051 microcontroller, it is a 40-pin IC. In that 40 pins, this EA is one of the pin. So here EA stands for external access. Okay, so this using this signal, it is used to access external memory. Either it is RAM and ROM for a microcontroller. So there is already embedded memory available. If that ROM and RAM, which is inside 8051 microcontroller, if it is not enough, there is also possibility of interfacing external ROM and RAM. So externally we can interface this ROM and RAM with the help of this EA pin. And next, what is the size of on-chip program memory and on-chip RAM in a typical microcontroller? So here on-chip program memory is nothing but on-chip ROM and on-chip RAM in a typical microcontroller. That means what is the amount of memory inbuilt? So 8051 microcontroller, internally it consists of program memory around 4 kilobytes, and internally it consists of data memory, that is RAM, which is around 128 bytes. And list out the advantages of using a microcontroller in place of microprocessor. That means what are the advantages if we use microcontroller instead of microprocessor? So when a microcontroller is used, on-chip peripherals are available inside microcontroller like RAM, ROM, IO ports, timers. So all these things are present inside the microcontroller itself. Okay, no need to connect them externally. So because of this reason, what happens means reduction of hardware. So because all these are present internally, no need to connect external components. That is why usage of hardware will be reduced. And what is the function of DPTR register? So we have seen 8051 registers. So among those registers, this DPTR is one of the register. So here DPTR stands for data pointer. So it is a 16-bit register. So this is the register used to read and write the data to the data memory pointed by DPTR register. So generally it is a 16-bit register. Next. So what is the function of RST pin in microcontroller? So we have seen the pin configuration of 8051 microcontroller. So in the pin configuration, it consists of 40 pins. Among that 40 pins, this RST is one of the pin. Okay. So here RST stands for reset. So RST, it is the 9th pin among 40 pins, which stands for reset. So it is an input pin. So this should be high for at least 2 machine cycles. So it is used to reset the values of 8051 registers. So generally when this reset signal is enabled, all the registers that are available in 8051 microcontroller will get reset. Now, which signal is used to enable external program memory? So if the internal ROM, here program memory means ROM. Okay, read only memory. So which signal is used to enable external program memory? Already ROM will be present inside 8051 microcontroller. If that amount of ROM is not enough, we can connect ROM externally also. But in order to connect external ROM for 8051 microcontroller, which signal should be used? So here PSEN, program store enable. So this is the signal we have to use. So among the 40 pins, this PSEN signal is the 29th pin. So PSEN stands for program store enable. So this is the output pin. Okay. So and it is used to connect the ROM, in the ROM especially for OE pin. So with the help of this PSEN signal connected to OE pin of ROM, it is possible to access external program memory. And so define ALE signal in the context of multiplexing address and data information in a bus. So what is here ALE signal means? ALE stands for address/enable. Okay. So it stands for address/enable. It is an output pin and it is active high. Now, so if we consider for 8051 microcontroller, there are 4 ports. So multiplexing address and data information. That means address and data lines are multiplexed. That multiplexed address and data lines are available at port 0. Okay. So port 0 can be used as two functions. One is port pins, another one is address data lines. So 8051 microcontroller port 0 provide both address and data. If the ALE signal is enabled, these address and data lines will get demultiplexed. Now, which ports are used to address external memory in 8051 microcontroller? So in order to access the external memory, okay, so this 8051 microcontroller is having 4 ports. Which port should be used in order to access the address external memory? So in order to access external memory in 8051 microcontroller, we have to use port 0 and port 2 pins that are available in 8051 microcontroller. And port 0 provides AD0 to AD7, that is multiplexed address and data lines, whereas port 2 provides simple address lines from A8 to A15. Next. So what is the purpose of DPTR in 8051 microcontroller? So here DPTR stands for data pointer. It is a 8-bit register that is available in 8051 microcontroller. Okay. So DPTR stands for data pointer. So it is a 16-bit register. So that 16-bit register can be used as two 8-bit registers. One is DPH, another one is DPL. So the function of how this 16-bit register is divided into two 8-bit registers means, so this DPTR is used to hold the 16-bit address. It can be manipulated as 16-bit data register as two 8-bit registers, that is DPH and DPL. It serves as base register in indirect jump operations and lookup table instructions and external data transfer. So during these operations, we have to use DPTR register. Now, so what is the function of SP in 8051 microcontroller? So here SP stands for stack pointer. So that is one of the register available in 8051 microcontroller. So SP stands for stack pointer, and the stack pointer register size is of 8-bit. And so every time the stack pointer register contains the address of the top of the stack, it is incremented before data is stored during push and call instructions. So when this push and call instructions are executed, the program counter will be, the stack pointer will be incremented. The stack array can reside anywhere in on-chip RAM. So the stack pointer is initialized to 07 when it is reset. Okay. So when it is reset, the register value will not goes to 0. Especially this stack pointer, when it is reset, it will be initialized with 07 only and not 0. So this causes the stack to begin at the location 08H, because it is during reset it will be initialized to 07. If it increments, then it goes to 08. So list out the special function registers available in 8051 microcontroller. So here special function registers means SFRs. Okay. So there are number of SFRs available. So different special function registers are B register, okay, program status word, stack pointer, data pointer, 4 ports, that is port 0, port 1, port 2 and port 3, and instruction priority control register, instruction enable control register. All these are different registers that comes under special function registers. And some more registers are also there. So define program counter and how it is useful in program execution. So program counter means PC. It is a register. Okay. So the program counter keeps track of the program execution. So that means it will see to execute the program in the sequential manner. Because, so to execute a program, the starting address of the program is located in the program counter. So the program counter holds the address of the next instruction that is going to be fetched. So the PC sends out the address to fetch a byte of instruction from the memory and increments its contents automatically. So after each instruction is executed, the program counter will be incremented by 1 so that it holds the address of the next instruction. And next, define stack. So here stack will be operating in LIFO mechanism, that is last in first out, which is implemented in the RAM area, and it is used to store the address and data when the microprocessor branches to a subroutine. Okay. So generally during this subroutine executions and all, we are going to use push instruction, pop instruction. So in order to store the contents after executing the before executing subroutine, it has to store the contents on the stack, and after executing the subroutine to the main program, it has to retrieve the contents from the stack. So that is why here the information of subroutine will be stored on the stack. Now, so what is the distribution of 128 bytes of on-chip RAM of 8051 microcontroller? That means on-chip RAM size that is available is 128 bytes. How it is distributed? So that 128 bytes have been distributed as register into register banks. So register banks, for register banks it is given as 32 bytes, and for bit addressable memory 16 bytes are given among this 28 bytes, and for general purpose RAM 80 bytes are given. So totally 128 bytes have been divided like that. So what is the need of auxiliary carry flag? So this auxiliary carry flag, we have seen the PSW format, that is program status word, which is called as flag register. It is an 8-bit register. Okay. Among the 8 bits, one of the flag bit is AC, which is called as auxiliary carry. Now, so what is the need of this auxiliary carry flag? That means when that flag will be enabled. So auxiliary carry bit is set if there is a carry out of bit 3. That means, in other words, for unsigned summed value of the lower nibble of the accumulator operand and the carry flag exceeds 15, the auxiliary carry flag bit is set. So for example, if you are performing 8-bit operations, okay, so if there is any carry from lower nibble to higher nibble, or if there is any borrow from higher nibble to lower nibble, then we can say that this auxiliary carry flag bit is set. Otherwise, the auxiliary carry flag will be cleared. AC will be 0. And what are the events that generate interrupts in 8051 microcontroller? Okay. So here 8051 microcontroller will be getting interrupts due to different events like timer 0 overflow or timer 1 overflow, and so transmission and reception of serial character, and external event 0 and external event 1. So all these are different sources that will be generating interrupts for 8051 microcontroller. Next, so how the carry flag is activated? That means in the 8-bit PSW program status word, this carry flag is one of the bit. So when this bit is set, so here carry flag bit, it is indicated as simply C. Okay. Now, so carry bit means if you are performing any 8-bit operations, if the result is greater than 8-bit, okay. So if you are performing any 8-bit operations, okay. So here carry bit means if there is any carry out of bit 7. That means if any 8th bit is developed, it is not able to fit in the register. In that cases, we will say that the carry flag bit is set. So in other words, we can say during unsigned summed value of the accumulator operand and the carry flag exceeds 255, carry flag bit is set. Otherwise, it will be cleared. Next. So what happens when an interrupt ends? So an interrupt ends when the program executes an instruction called RETI. So here RETI stands for return from interrupt instruction. Now, so 2 bytes are popped from the stack into the program counter in order to restore the normal program execution. Then only the control will go to the main program and execute the remaining lines. So interrupt status is restored to its pre-interrupt status. Now, so what happens when an interrupt occurs? So another reason is here, the current program counter will be saved on the stack, that is lower byte first, and interrupt of the same and lower priority will be blocked. Whereas in case of the timer and external interrupts, the corresponding interrupt flag bit will be cleared. Now, so program execution transfers to the corresponding interrupt handler vector address. So this is what happens generally when interrupt occurs. So the interrupt handler routine executes. That means the interrupt service routine will be executed. Now, how baud rate will be set in 8051 microcontroller? So 8051 microcontroller, in order to set different baud rates, it is completely dependent on the oscillator frequency. Okay. So here generally this microcontroller can be operated in different modes like mode 0, mode 1 and mode 2. Here the baud rate can be determined by setting the oscillator frequency when it is operating in mode 0 and mode 2. So in mode 1 and 3, the baud rate is determined by how frequently the timer 1 overflows. Okay. So based on different modes of operation, the baud rate will be determined. So the more frequently timer 1 overflows, the higher the baud rate. So if the baud rate is high, the timer will be overflowed. Next. So how timer mode 2 operates in 8051 microcontroller? So here we have timer counters available in 8051 microcontroller. So how timer will be operating in mode 2? So when the timer is operating in mode 2, it is called as 8-bit auto reload mode. So when the timer is in mode 2, the THX, that is timer, H stands for higher, it holds the reload value, and TLX, so TL stands for, it is a 16-bit register, TL stands for lower order 8 bits and TH stands for higher order 8 bits. So when it is operating in mode 2, TH value holds the reload value, whereas TL value is the timer value. So always the TL value starts counting up. So when TL reaches 255 and if it is again incremented one more time, instead of resetting to 0, it will reset to the value in THX. So that is what the timer overflow. So what is the sequence of operation when interrupt occurs? Okay, generally when interrupt occurs, what the microcontroller is going to do? So when interrupt occurs, 8051 microcontroller puts on hold the normal execution of the program, and then it goes to execute the special selection of the code referred to as interrupt handler. So whenever interrupt occurs, the microcontroller stops whatever it is doing and then it goes to the interrupt service routine in order to execute that. Now, so the interrupt handler performs whatever special functions are required to handle the event. After executing that, again the control will be going to the main program where it has stopped, and then again it continues. Next, so what is the role of SCON register for serial communication? So here SCON stands for serial control. So the serial control is used to configure the behavior of 8051 onboard serial port. So here this SFR, that is a special function register, it is SCON is a special function register. It is used to control the baud rate of the serial port whenever the serial port is activated to the received data, and also it consists of flags that are set when the byte is successfully sent or received. So by using this SCON register only, we can transmit the data and receive the data, and we can know whether the data is transmitted or received. Next, so what is the purpose of TCON register in 8051 microcontroller? So here TCON stands for timer control register. So this is one of the registers that are available to perform that timer counter operations. So this TCON register also comes under this SFR, that is special function register, used to configure and modify the way in which 8051 microcontroller operates. Okay, so it consists of two timers. So this TCON register is related to 8051 two timers operation. So this TCON register, it is going to control whether each of the two timers is running or whether they are stopped, and we can also know whether it contains a flag to indicate that each timer has overflowed. Okay, so if we see the TCON register format, all the bits that are present in that format will says all this information. That means whether the timer is running or whether the timer is stopped, okay, or whether the timer is overflowed, which timer is overflowed, because it is having two timers. Now, how SCON register can be used for serial communication? So SCON stands for serial control register. It is used to configure the behavior of 8051 onboard serial port. So this is an 8-bit register. Using this special function register only, it is used to set the baud rate of serial port, whether the serial port is activated to receive data, and also it consists of flags to set whether to know the information, that is data that is sent or received successfully or not. Next, so what is the role of SBUF in the context of serial communication? So here this register is also related to serial communication. So here SBUF stands for serial buffer. It is not bit addressable. It is simple register that is available at the transmitter end and receiver end. So it is used to send and receive data through the onboard serial port. So any value that is written into this serial buffer will be sent out of the serial port TXD pin. Similarly, at RXD, that is at the receiver end also, we will have one SBUF register. So 8051 receives the data which is present at the serial port through RXD pin, and it will be kept in this SBUF register. Next, how logic 0 is represented in RS-232. So here also there is a RS-232 cable which is used to perform the serial communication. In 8051 microcontroller, how to represent logic 0. So logic 0 can be represented with the help of voltages that are present in between plus 3 volts to plus 12 volts. Okay. So this is used in long distance communication. Next. So what is RS-232C standard? So RS here stands for recommended standard number. It is used to perform the serial data communication. So this RS-232 is a serial bus consisting of maximum 25 signals, and this RS-232 is provided by EIA, that is Electronic Industry Association. So this is a cable which is used for producing serial communication. So among these 25 signals, only 9 signals will be used for performing the serial data transmission. Next. So how timer mode 1 operates? So timers generally it can be operated in different modes, but when this timer is operating in mode 1, what is the function? So when it is operating in mode 1, it is acting as a 16-bit timer. Okay. So this TL is incremented from 0 to 255. And when TL is incremented after 255, it resets to 0. So why? Because the maximum value is 255. If it increment after 255, again it resets to 0 and causes THS to be incremented by 1. So this is what called the timer overflow. So since this is a full 16-bit timer, the timer may contain up to 65,536 different values. Next, when overflow flag bit is set. Okay, so this is one of the flag bit that is available in the PSW format. So overflow means we can observe in the PSW format bit as OV. Okay, so when this bit is set means if there is any carry out of bit 6 or out of bit 7, we will say that the overflow flag bit is set. That means if you are performing any 8-bit operations, the result should be within 8-bit only. It should not exceed more than 8-bit. Now, otherwise this flag bit will be cleared. Next, so what are the benefits of auto reload mode? So this auto reload mode is one of the mode of timer operation. So when we want the timer to always have a value from 200 to 255, then we have to operate timer in the auto reload mode. Now, so if we use mode 0 or mode 1, we have to check in the code to see if the timer has overflowed and if the reset the timer to 200. So because of this reason, it takes the instructions of execution time to check the values, and every time we have to reload it. That is why it is better, instead of doing that, if we operate the timer in auto reload mode. So it is we can avoid every time checking whether the timer has reached the condition or not. So when we use mode 2, the microcontroller take care of this. So this auto reload mode means timer mode 2 operation. Now, how split timer mode operates in 8051 microcontroller. So this is also one of the mode of timer operation. So when the timer is operating in mode 3, it is called as a split timer mode. So when timer 0 is placed in mode 3, it essentially becomes two separate 8-bit timers. So that is splitted into two 8-bit timers. So that is why it is called split timer mode. So timer 0 having TL0 and timer 1 having TH0. So these are the two splitted timers when it is operating in split timer mode. And both timer will be counting from 0 to 255 and overflow back to the 0. That means after 255, if it is incremented again, it goes back to 0. And all the bits that are related to timer 1 will be related to TH0. And what is the relation between resolution and number of bits in ADC? We have seen how to interface IO devices to 8051. So the relation means the resolution increases with the number of bits in ADC. And for example, if you take 8-bit ADC, it is going to produce best resolution compared to 4 bits. Define internal and external interrupts. So internal interrupts means the interrupts that are taken by the inside the chip. Okay. So internal interrupts are activated by the mechanism inside the chip, whereas external interrupts are activated when the signals are received at the input pins of the chip. That means if there is any interrupt coming through the port pins, then it is called as external interrupts. How timer interrupt is generated? So we have two timers available. So for example, if you take a timer can be operated in different modes, especially if you take in mode 1, timer 1 register overflows when the register count reaches to FFFF and it allows again to increment by 1, it goes back to 0, 0, 0, 0. That means it will be resetting. And after generating the timer interrupt. What type of communication is used in long distance? So for long distance communication, we are going to use serial communication by using RS-232 cable. So this is used to reduce the cost of physical mediums. Why? Because using single wire, bit by bit transmission will be performed. Next, define baud rate and bit rate. So here, baud rate means number of symbols transmitted in 1 second, whereas bit rate stands for number of bits transmitted in 1 second. How logic 1 is represented in RS-232 levels. So, in between which range of voltages to represent logic 1 means, we can use any voltage within the range -3 to -25 volts to represent logic 1. So this is useful in long distance communication. So what is the necessity of external memory interfacing in a microcontroller? So already inbuilt memory is there. If it is not sufficient, we have to go for connecting memory externally. So the designer of 8051 microcontroller based system is not limited to the internal RAM and ROM inside the microcontroller. So in any cases, if it is not enough, both external RAM and ROM can be connected externally. There is also a provision because we have port pins. So the reason of interfacing external memory or ROM is that maybe when the complex programs are executed, the internal memory is not enough. So that is why we have to go for using the external memory, which need to occupy more space. How much maximum external memory can be connected in a microcontroller with 16 address lines? So what is the maximum external memory we can use by using the 16 lines? So maximum 64 kilobytes of memory can be connected by using 64 address lines of 8051 microcontroller. Next. So what is the need of data converters in microcontroller? So digital processing and storage of physical quantities like sound, temperature and pressure, the advantages of digital electronics. Okay. So digital data converters means, because here those are the devices that will be understanding only digital information. So that is why we have to go for using data converters. So data conversion is better technology to use instead of going for analog. So what is the purpose of this data converters means? It is more reliable in terms of storage, transfer and processing the information. So what is the function of timer in a microcontroller? So generally timers are available in the microcontroller in order to produce the delay. So the timer is specialized type of clock which is used to measure time intervals. So the timer that counts from 0 upwards for measuring time, it is called as stopwatch. If the device that counts down, okay, for the specialized time interval and use it to generate a time delay. For example, the timer that is going to count down means, the example is here hourglass. And what is the function of counter in a microcontroller? So here counters are used to count the number of external events that are happening outside the microcontroller. So the counter is a device that stores the number of times a particular event or the process occurred with respect to the clock signal. So it is used to count the events happening outside the microcontroller. So in electronics, counters can be implemented easily by using register type circuits such as flip-flops. So what is the function of timer mode register in 8051 microcontroller? So here timer mode register stands for T mode, which indicates the mode of timer operation. So T mode is a special function register. It is an 8-bit register for selecting timer or counter modes of operation. So decide the modes of timer operation. So lower 4 bits of this T mode register, it is used for control operation of timer 0 or counter 0, and the upper 4 bits are used for control operation of timer 1 or counter 1. So this register is related to the special function register. The address of special function register of this T mode is 89H. So this is what about the definition and terminology related to module 5, that is 8051 architecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.